My dear friends, for the exam point of view, what are the previous questions they asked? How can we write the answers from human eye? Very simple. Everybody concentrate here. For each and every lesson, we'll discuss further videos. Now, this is the first video of revision of the SSC 2022. See, yes, about human eye, what type of questions they asked? See, very simple. They asked in the previous examinations about what is the function of cones, what is the functions of rods, what is the importance of ciliary muscles, and also from iris also they asked the application question. See, first we'll go for the cones and rods. Cones are used to see the colors in your surroundings. Cones can identify the color, intensity of color. Remember, and also you can write, if cones are absent, the person may get color blindness. Whatever the color. Very important. What is the cones? Cones can identify the colors, intensity of color. Due to absence of cones, the person may get the color blindness. Next, rods. Rods can identify the intensity of light. Daytime, nighttime, that can identify. Due to absence of rods, the person may get a night blindness. In general, we call it as ray chikati. After 6 o'clock, they can't see. Now, next one is iris. From that, they asked in one question. When you come out from cinema theatre, sometimes you are unable to see the surroundings clearly. Why? Remember, because iris. What is the function of iris first? Iris can change or control the size of pupil. Pupil size is there. This is the pupil. This is the iris. That pupil size controlled by iris. When you are in dim light, that pupil size has to increase by the iris so that more light enter into your eye, so you can see something in the dark also. But when you are in bright light, the iris has to decrease the pupil size so that less light will enter into your eye, then it is very safe. You can see clearly. If more light enters, your retina will damage. So what? Decreasing when you are in bright light. For example, if you see light bulb very close and turn and see once, it appears very black. Yes, because in dim light that size has to decrease. When suddenly if you turn back, it is low light. So pupil size has to increase. Then only you can see. So to increase, it will take some time. Yes, the answer is, when we come out from cinema theatre, we are unable to see the surroundings sometimes because in cinema theatre, our eyelid pupil size has to decrease because we are in bright light. When comes out dim light, so pupil size has to increase. To that, it will take some time. So that's why in that duration we can't see clearly the objects. Next question. If ciliary muscles does not work properly, what will happen? Very important question. First we'll go for the ciliary muscle function. Ciliary muscles are used to change the focal length of eyelids. The changing focal length is called accommodation. Accommodation means adjusting the focal length of eyelids is called accommodation of eye. When we are observing far objects, our eyelids has to be maximum 2.5 centimeters. When we see near objects, our focal length has to be minimum, that is 2.27 centimeters. If not work, that means when you see the far object, that focal length 2.5, when you see near 2.27, if not adjust, you can't see all the distance objects, near objects, far objects, you can't see. That condition may leads to vision defects, myopia, hypermetropia. So what you understood? If ciliary muscles not work properly, we can't see all the distance objects. The person may get the vision defects, myopia or hypermetropia, we don't know. So very, very important. One more important question they asked. A person's eyelids not accommodate more than 2.4 centimeters. What will happen to the person? Very simple. Actually, our focal length is 2.27 minimum and maximum 2.5 centimeters. 2.27 is the minimum, 2.5 is the maximum. If anybody has 2.27 minimum focal length, they can see near objects clearly. If any person has 2.5 maximum focal length, that person can see far objects clearly. But our question, the person's eyelids not accommodate more than 2.4. It is not going more than 2.4. So, you can't see far objects clearly, because if it is 2.5 you can see far, but it is not 2.5, 2.4 only maximum. So that vision defect is called myopia. They can't see far, they can see near okay, but far is different. So very, very important. This question everybody is confusing once again. A person's eyelids not accommodate more than 2.4 centimeters. What will happen? Answer is, the person can't see far objects, because when they see far object, the image forms in front of the retina. They can't see. Very, very important. Yes. Next, from vision defects, they are asking different questions. In last time they asked them, how can you correct the myopia vision defect? Very simple. Myopia vision defect we can correct with by concave lens. Draw the correction ray diagrams, most important. Frequently they ask, even CBSE, even state. So before that we'll see something. So myopia means what? Myopia means the person who can see near objects clearly but not far objects. Hypermetropia means the person who can see far objects clearly but not near objects. Near means this L2, L is the least distance of distinct vision, 25 centimeters. Average. Least distance always 25 centimeters. H is called near point. M is called far point. This is a far point, that is a near point. See, for example, when this person, myopia person, if sees far objects, the image forms in front of the retina. When the object is infinity, like this, image forms here only. Because that focal length is not 2.5, maximum focal length is not 2.5. So, image forms in front of the here, the person when see near objects, the image forms beyond the retina. When see near objects, beyond retina. Very, very important. To correct these defects, myopia can correct by concave lens. this hypermetropia corrected by convex lens. So this is the infinity object. When falls on lens, diverges because concave. So extend back. Here the image will form. This image this person can see because ML middle he can see. Near objects he can see clearly. So the image forms on retina direct when I take the lens. When I use the lens, image forms in direct on retina. In this case, when object is very close to the lens, you know, in the convex lens, when convex lens, if I take the object between F and P, the image forms beyond the object only. Same image. Here when I take convex lens, the image forms back. Image forms back. So after H, if it is image, you can see, because for objects clearly you can see the image forms on retina direct. So these are the correction ray diagrams. Even they asked focal length also sometimes. How to do the focal length, we'll see. Questions. Priya's grandmother unable to read the newspaper. What is her vision defect? Once again listen carefully. Priya's grandmother unable to read the newspaper. What is the vision defect? Newspaper means very near. She can't read. Near objects she can't see. So what is the vision defect? Near objects can't see means it is hypermetropia. Far she can see. So hypermetropia vision defect. What type of lens we should use? It is convex lens. One more question. Kirti unable to see the blackboard from last bench. What is her vision defects? From last bench she unable to read means far objects she can't read. Far objects she can't see. Far can't see means myopia. She can see front clearly. She can sit front bench. Clearly she can see. In this way they are asking application questions. Be careful, everybody. Correction ray diagrams asking compulsory, and the questions also different questions they are asking. Yes, the next question. They are asking how to find the focal length of the lens to a particular person. Same focal length we should not use for all the vision defects persons. Different. Depends upon the distance, how much distance they can see clearly. See, these questions are asked for 4 marks. Simple, for myopia focal length and hypermetropia focal length. Very simple. First correction ray diagram you have to draw it. So here see, correction ray diagram. So this myopia is corrected by concave lens, double concave lens. So for this person, infinity object we have to take care, because infinity you can't see. For that we are going to show. Infinity, when object is at infinity, image forms between L and M. So the person can see clearly. So this is image actually. So object where it is, infinity, minus, image also minus, D, up to here we are taking as a D, up to M. So focal length we can find. The lens formula is 1 by F is equals to 1 by V minus 1 by U. Simply V means minus D, image distance, minus 1 by minus infinity. So 1 by F equal to minus 1 by D, because 1 by infinity value is 0. So plus 0 minus 0 whatever, 0. So reciprocals when changed, F equal to minus D. This is the focal length of a myopia person. Very easy. But see here, little bit. So for that person, we should use convex lens. We know already. Correction ray diagram I am going to draw. So where should I take the object? At a near distance I am taking the object. Then image forms and retina. The image is here like this. Very important. Here image will form. After H it can form the image. H, after H you can see. So up to H I am taking distance D, image distance I am taking as D, objective distance minus 25, image distance minus D, because after D it can form. Focal length is F. 1 by F equal to 1 by V minus 1 by U is the length formula. Just 1 by F equal to 1 by minus D minus 1 by minus 25. L is the 25 distance. So I am taking 1 by F equal to LCM 25D minus 25 plus D. So here see, when I change the reciprocals, F is equals 25D by D minus 25 is the focal length of hypermetropic person. Based on this also may ask some problems from the entrance examinations. See, one more question. Doctor advised to person A use plus 2D lens. Doctor advised to B use minus 3D lens. They are asking some questions here. What is the vision defect of A? Very simple. If it is plus, remember it is convex lens. Convex lens is used to hypermetropia. So vision defect of A is hypermetropia. What is the vision defect B? Myopia because of minus. What is the focal length of person A? And what is the focal length of person B? Very simple. Power, if they given, we can find the focal length very easily. Power P is equals to 100 by F should be in centimeters. So F, if I take that side, 100 by P will come. So 100 by P means 100 by 2, that is 50 centimeters is the focal length for the person A. Person B also same, 100 by 3, 33.3 centimeters for the person B focal length. Very, very simple. What is the nature of lens for A? A nature of lens is convex. Nature of lens for B is concave. This type of questions also asking. Very, very important. So everybody just concentrate on human eye. What we discussed the questions, very, very easy. Almost the questions will come in this manner only. So everybody has to prepare once, twice, just listen carefully, you can get the answers. Thank you so much. We'll see the next lesson next video.